In this video, we show how to calculate the derivative of a logarithmic function. Let's jump right into the problem and calculate the derivative of the logarithm of base 3 of x. To calculate it, we first look at the general rule. The rule says the derivative of the logarithm of base a of x is 1 divided by the product of the natural logarithm of a with x. This is only defined for positive a. We have the same form with a equal to 3, which means we can apply the differentiation rule and substitute a by 3. We obtain that the derivative of the logarithm of base 3 of x is equal to 1 divided by the product of the natural logarithm of 3 multiplied by x. This concludes our first example. Let us now consider a function that is not just the logarithm of x and calculate the derivative of f of x equals to the natural logarithm of 4 times x plus 3. Recall the natural logarithm is the logarithm of base e. We need to apply the chain rule to the logarithmic function. Recall that for f of x equals g of h of x, the derivative is given by g prime of h of x times h prime of x. In our case, g of x is equal to the natural logarithm of x and h of x is equal to 4 times x plus 3. We calculate their derivatives, which are g prime of x equals to 1 divided by the natural logarithm of e multiplied by x, and h prime of x is equal to 4. We use them to obtain the derivative of f of x, obtaining 1 over the product of the natural logarithm of e with 4 times x plus 3, all multiplied by 4. Our first simplification comes from the fact that the natural logarithm of e is equal to 1. Next, we rearrange the terms. We obtain that the derivative of the natural logarithm of 4 times x plus 3 is equal to 4 divided by 4 times x plus 3. This concludes our examples. Thanks for watching.